Hello friends, today we are going to discuss the topic factorials, in which they used to ask a question that is trailing zeros. Now first part for this is what is trailing zeros. In short, if I go in the term 1000, these are the trailing zeros, or 1200, these are the trailing zeros. What trailing zero means? The tail of the numbers which are having continuation of the zeros. So maximum number of zeros at the end of the number is a trailing zero. And why they ask in factorial? For simple example, we know what is factorial. 2 factorial is 1 into 2. 3 factorial is 1 into 2 into 3. 4 factorial is 1 into 2 into 3 into 4. That means factorial goes with the continuously multiplication up to that number from 1 itself. So they will ask a simple question by saying, for first simple example, 100. What is the number of trailing zeros in 100 factorial? For simple example, if I expanded 1 into 2 into 3 into 4 into 5, keep on till 100. How many zeros do I have at the end of the number after taking the product of all? If you say 10, 20, 30, 40, 50 until 100. 10 till this plus 1, 11. If you go in this way, then this is the wrong one. Why? I'll explain you in a proper way. Now see. The smallest possible number with the least number of zeros is 10. How to form this number? 2 into 5. So, to form 1 0, I need 2 to the power 1 and 2 to the power and 5 to the power 1. That is, to form 1 0, this is the necessity. Now, write 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This up to 10 factorial. The same way goes till 100 factorial. You all have counted this. What about this pair? And 2 from this and 5 from 15. 2 from this and 5 from 25. Where it goes? So basically I need to find the number of 2's I have in 100 factorial and number of 5's in 100 factorial. Then I need to find the common power. This is what I have to do. So go in this way now. Take a sample space. Take a sample space. In 10th, in 11th and 12th class we have done with the physics. For simple example, if this is the diagram of something and I need to integrate it, so we have taken this is as a sample space dx. Then we integrate it as dx. The limits are fixed. We have fixed the limits. So in this case, this is my own sample space. You can take it by factorial. Any factorial value. Now, if I explain a proper way, then simple goes in this way. 2 persons or 2 companies I had to form this marker. Now to form this marker, I need a cap and a other part. If I have 100 caps and 90 markers, how many complete marker I can sell? 90. This is what I can do now. Only pen I can't sell, only marker I can't sell. So I know the body of the pen is the limiting factor for me. So if I am able to find which one is the limiting factor out of this and I count that, that is my answer. इन दोनों में से जो भी कम अमाउंट में अवेलेबल होगा मैं उसी को काउंट करूंगा. दिस इज स्मार्टनेस है, क्योंकि मुझे पता है इन दोनों का कॉमन पावर चाहिए, तो कॉमन पावर जिसकी कम होगी उतना ही कॉमन निकाल पाऊंगा. सो हम उसी चीज को ट्राई करेंगे बाय टेकिंग द सैंपल स्पेस ऑफ 5 factorial. In 5 factorial, write all this in a prime factors. 1 into 2 into 3 into 2 square into 5 to the power 1. So in this, I am having 2 to the power 3 and 5 to the power 1. In my own created sample space of 5 factorial, I get to know that 5 is the limiting factor. If I am able to find the number of 5's in 100 factorial, that is my answer. So let's try how to find this one. Now I know the limiting factor is 5. So I am going to count 5 only. So how can I count? First, I'll go all those numbers which are having 5 to the power by 1. 5 to the power 1. Why? I'll tell you step by step. Then I'll go for 5 to the power 2. Then I'll go for 5 to the power 3 and so on. Why? Again, take an example. In a class of 30 students, I need to collect the money with the multiple of 5. First, I will say those who are having the value more than 5, just raise your hand. I'll take 5 rupees. It is done. The number of students which are not having amount equal to 5 or more than 5, those are already neglected. That means they don't have 5. For simple example, in 10 factorial, 1, 2, 3 and 4. These are neglected because they don't have any 5 in it. Second, again I will say, after completing the first round of collecting 5 rupees from everyone, again I will say, now again give me 5 rupees. Now those who are having 6 rupees or 7 rupees with them, they don't have 5 rupees for the second round. Why I am doing so? Just go in this way, 25. He has 2 5 with him and both are in multiplication. He has given 1 5 in this case and he left with 1 5. I have to take care of this. Now, do I take another 5 out of 100 factorial? For simple example, do I have any number which is having 5 to the power 3 in it so that I can collect it? I don't think so, because 5 cube is 125. So till 100 factorial I don't have 125. So to find this out, we'll go in this way. The number of 5s which are having 5 to the power 1 is 100 by 5, that is 20. 5 square, 100 by 5 square, that is 100 by 25, that is 4. Is it possible 100 divided by 125? No. So remove this. Now add this value, that is 24. So in this case, I have 5 to the power 24 is the maximum power obtained by the 5. And this is the limiting factor. So in 100 factorial, the trailing zero count is 24. Because I have 24 5s and that can be counted by this way. So go in with another example. I have written this as it is. Now, same trailing zeros in 125 factorial. Again, 10, 2 into 5, limiting factor again remains 5 because we have checked in the sample space. So count how many 5s do I have. 125 divided by 5 plus 125 divided by 5 square plus 125 divided by 5 cube plus 125 divided by 5 power 4. This is 5, this is 25, this is 125, this is 625. Possible? Not possible. So I'll go with this. No need to take the decimal value. Just go with the natural value or the part before the decimal. 25, 5 plus 1, 31. So 31 5s or 5 to the 31 is coming under this. So this is the first part of trailing zero. Now the other part is exponential power. Exponential power and trailing zero remains same. In trailing zero, we are bound to 10. That I need to prime factorize it this and find the limiting factor among this and solve it. The other part is exponential power. Then I need to prime factorize the number. For simple example, I go and ask, what is the exponential power of 6? Exponential power of 6, this is what they are asking for in 100 factorial. What is the exponential power of 6 in 100 factorial? So same, find the limiting factor first. So limiting factor for this, take the sample space 1 into 2 into 3 into 4 into 5. Go in prime factorization. So in this, I have 2 to the power 3 and 3 to the power 1. So which one is the limiting factor? Why I went with this? Prime factorize the 6. That is 2 into 3. Any one of the above can be the limiting factor. So this is the way I have to go. Now 3 is the limiting factor. I will count 3 in 100 factorial. How? The same way. Limiting factor is 3. So count 3. 100 upon 3. 100 upon 3 square. 100 upon 3 cube plus 100 upon 3 power 4. I can't go with 100 upon 3 power 5. That is 243. तो ये possible नहीं है. So in this way, what is 33? This 11, this 3, this 1. How I am doing it so fast? Just go in this way. 33 divided by 3, 11. 11 divided by 3, 3. 3 divided by 3, 1. Because I am raising the denominator. So add it. 44 plus 48. So 6 to the power 48 is the answer. Why? To form 1 6, I need 1 2 and 1 3. So I solve in this way. I hope you like this video. So do not forget to subscribe.